For a few years now, a good friend of mine has let me keep one of these mini PCs around his house. He's got symmetrical gigabit internet, so it makes it quite a good location to have as an off-site backup. If we open it up, we can see there's room for a 2.5-inch hard drive or SSD. But unless you're willing to pay a lot of money, you're not going to store much in this form factor. So I had the idea of attaching a 3.5-inch hard drive to this PC, or not this PC specifically, but the actual PC that lives around his. You can see on screen now a few pictures of how I've had this PC set up in the past. The hard drive was suspended in some bungee cord so that it didn't make noise or reduce the amount of noise, because it was living in his bedroom, so having it as quiet as possible was the highest priority. It also had several Noctua fans that were keeping it nice and cool. It was all open, so the Noctua fan was blowing straight into the PC, and it was staying relatively cool, at least on the PC side, but with where the hard drive was underneath, quite enclosed, that was heating up. And when opening it up in Crystal Disk Mark, it was at a temperature for most of the time that I wasn't entirely comfortable with, so it's led me to want to improve the casing that I made for it, and it's also a good opportunity for me to make a few more changes, so I may as well talk through them now. So I've replaced the Pi KVM that I did have with this Sipeed NanoKVM, because it's a much smaller form factor and does everything I need it to do. I discovered quite early on that I needed to connect the NanoKVM directly to a display port, because this PC came with an HDMI port in this slot here using the HP Flex IO system, but for some reason you can't access the BIOS using this HDMI port, so it meant I had to use a DisplayPort to HDMI adapter. I also have this male-to-male HDMI adapter, which then connects directly into the NanoKVM. I 3D printed a little bracket for the DisplayPort to HDMI adapter, so that it stays in there nice, and there's not enough wiggle room or movement so that the NanoKVM touches the motherboard. I attached this SATA connector that I retrieved from this PC, because this PC didn't come with the hard drive caddy. If this PC had come with the hard drive caddy, it would have come with a chassis fan, but it didn't, and nor did this PC. So this PC is a 35 watt PC, whereas this is a 65 watt PC. With it being 65 watt, the motherboard expects that there could be more heat within the casing, so a chassis fan is kind of requested by it. When you turn it on, a BIOS message appears, and it doesn't automatically pass that message until you press enter on the keyboard. So it kind of led me to need to get a chassis fan for this motherboard, but because I'd already designed my 3D printed case without accounting for needing a chassis fan connected, I didn't have much room to include the chassis fan. So what I ended up doing was slightly modifying the fan to remove the fins and the casing, and I added a standoff. See if you can see that. Which is intended to just screw onto the side of my 3D printed chassis. I've also got these wires here that end up going to the power cable and the LEDs. It's not the neatest of soldering jobs and is kind of held in place by hot glue, but it does the job, and it doesn't look tidy now because it's a little bit covered in dust and the hot glue has yellowed over time, but it's stood the test of time and still works. But one of the problems I have is that the NanoKVM doesn't have ATX power, LED or button capabilities. So what I've done is, in this box I've ordered some boards. So these allow me to connect ATX power buttons and LEDs to the NanoKVM. I will solder on a female header here, which then intends on sliding onto the side of the NanoKVM like that. I found the schematic for this circuit on the Sipeed GitHub, as the larger NanoKVM comes with this circuitry and it's open source. So I just made a copy of that schematic, spun up a PCB and sent it off to the PCB manufacturers, which you can probably tell who they were by the colour of the box. As an improvement to my previous bungee cord hard drive mount, I found this design on Thingiverse, where you use some bungee cord threaded through some holes. I modified it to add some holes for threaded inserts, the idea being that without having to take apart the whole PC, I can just take the hard drive out and replace it or do what I need to do to it. You can see that this is a 20 terabyte hard drive that I shucked from an external hard drive. I was previously using the USB to SATA adapter that this hard drive came with, but to help simplify things and kind of minimize the amount of size that my PC would take up in my friend's house, I decided to utilize the motherboard hard drive connection, which has some drawbacks that I'll explain shortly. But with this, it does a fairly reasonable job of reducing vibrations. It's not as good as it was with my other bungee cord solution, but it removes a lot of the vibrations. So to be able to connect to this hard drive to the SATA connection on the motherboard, I got a SATA extension lead, and as you can see I've slightly modified it because I needed to be able to power this 3.5 inch hard drive with 12 volts, and you can see I've damaged that connector there, so that will need replacing. But the motherboard of the HP mini PC wouldn't supply 12 volts to this hard drive, so I'm injecting it using this XT60 connector. And I've just put a bit of heat shrink on this end to keep them protected. But with this, I can plug the hard drive in, plug this into the motherboard, and give it a bit of 12 volts, and the hard drive spins up nicely. I've spent quite a while designing this new 3D printed housing for this PC and hard drive, and I've got part of it printed here, as I need to insert the threaded inserts so that I can attach some of the things. So I'm going to do that now. So that's all the threaded inserts in now. So this is where the fans will go. I've got two 60mm Noctua fans that will go there and there. Then on this side I've got a portable router that will go there, and a couple of buck boost converters. So this part here is where the mini PC is going to mount to. It's got VESA mounting holes on the bottom of it, so I've just got a few holes here with a few recesses to put the screws. So we shall attach that now. So now with the mini PC attached to the 3D printed housing, I can go ahead and start attaching the standoffs for the router and buck boost converters. I'd forgotten about the 30-minute record limit on my camera, and I was working away at this without realising that my camera had stopped recording. So I'd made some progress, but just decided to carry on working on it off camera, and I am now at a point where I think I am pretty happy with it and ready to show you again. So the mini PC is mounted to the 3D printed housing along with all the other bits. Over here we've got the portable router, so we've got some Ethernets going into it. It's powered by the 5V buck boost converter through this USB-C cable, which is connected to a XT60 connector that goes into the buck boost converter. I decided to adopt the ATX power colours, maybe with the exception of this blue wire here. So we've got 12 volts in yellow and 5 volts in red. I've also attached the router's wireless antennas onto some standoffs just to raise them up. They're probably not optimal in this way, but quite frankly I'm not intending on using the Wi-Fi capabilities of this router anyway. I have a USB voltage converter that I've taken the USB connections off of and soldered directly onto, and on this end I've got a fan connector soldered into the output of the converter. So with this I can adjust the fan speed once the fans are plugged into it. I've got this power connector here that I bought off AliExpress that goes into an XT60 connector, and on the other end we've got this DC barrel jack that will be attached to the side of the case once I've printed that. We've got the chassis fan connected to the housing, and it's connected to the motherboard over here. And we've got the hard drive SATA cable coming through this slot, and I've just cable tied it to keep it neat. And I've just secured the motherboard to SATA adapter using a standoff. The NanoKVM has my PCB that I made attached to it with the cables from the LEDs and the power button attached to it. I've not managed to see the LEDs working on the NanoKVM web interface, but the power button works, and that's the most important thing for me. And we've got Ethernet going into it that's attached to the portable router. It's powered by 5 volts that I've soldered directly onto the board, and the USB-C cable plugs into the PC so that the keyboard and mouse works. I discovered that while the USB connection was plugged into the PC, the NanoKVM was backfeeding power into the buck boost converters. So after a little bit of research I discovered that there's a 0 ohm resistor that needed desoldering to isolate the USB-C power from the power I was providing externally. So with these 3 Ethernet ports, I've got one Ethernet going to this female to female adapter with the intention of attaching a panel mount Ethernet cable to. One goes into the NanoKVM and one goes into the back of the PC. And I've attached the fans on this side with some screws, and when it's finished the whole PC will be sitting essentially upside down with the hard drive on top, the PC below. There'll be a fan at the bottom that draws air in, and it'll be blown over the PC, round to the back, through the area where the hard drive sits, and these fans will blow it out. So this will be the back with the power and an Ethernet panel mount connector. And this will be the front with something over the top, held in place by the top and bottom plates that I need to 3D print. I discovered that the 3D model that I found for the buck boost converters didn't match the actual buck boost converters I had. These two holes lined up, but from there to there didn't line up, and I had a few other tweaks to make, so I just decided to re-3D print this enclosure without the threaded insert holes there. It also means I can more easily tuck wires and stuff behind. You can see on screen now the 3D model that I've made in Fusion 360. Once I've 3D printed these, I'll attach them and the project will be complete. But I thought I'd show you now while it's open so that you can see my vague attempt at some cable management. Once I've got the rest of the bits 3D printed, I'll show you the assembly. But essentially the fan cables will go through here and connect to some sort of fan splitter, and the bigger Noctua fan will sit here. And this is the fan I'll be using. It'll just sit there. It's got a height of 15mm, so nice and thin, and it should just sit there nicely, and it'll be attached to the panel that sits on the bottom. So while it's on the desk like this, we may as well plug it in and see it power up. We'll do it this way around so that we can see all of the lights light up. And I'll also show you the Sipeed NanoKVM interface where I can power the PC on through that web interface. So I'll plug some Ethernet in, if I get it around the right way. The tab on this cable is broken. I need to recrimp a new connector onto the end of it, but it'll do the job for now. And it's designed to use a standard HP power supply that came with the PC, just because it's easy, it works, gives 19 volts and plenty of amps. So we'll plug that in now and hope no magic smoke escapes, and we can see things start to light up. Since the KVM is behind the router, I can't talk directly to it from my main network. So I've enabled Tailscale, which I use for a lot of things, and I can just connect to the Sipeed KVM using Tailscale to get around this problem. To get the KVM working in the BIOS of the HP PC, I had to make a few changes to some settings by SSHing into the KVM and changing them. There was some post on GitHub that I saw where others had experienced issues accessing the BIOS of their HP PCs, and someone had posted what to change, so I did that. So I'm in the KVM's web interface, I've logged in, and I can click the power button through it, so let's do that now. The fan starts to spin. It always does this. The HP PC seems to turn on a little bit and then turn off, and it's sometimes a bit worrying if you just expect it to turn on, but it just does that. HP things. And we can see the PC starting to boot. The hard drives just spun up, and just like that we're loaded into Windows. So the next clip you'll see is me putting the panels on that I still need to 3D print. But once that's done, that's project complete. So I've got all the case bits 3D printed now. I've added some threaded inserts to the bottom so that I can add some feet. We've got the bit that goes on the front with some threaded inserts. We've got the back with spaces for the fans. The fans don't attach to this, so there's no holes for that, but we've got threaded inserts there as well. A space for the Ethernet cable and a space for the power connector. And the top. So I did this on a textured sheet. Unfortunately it did come up with that little bit of imperfection there, but it will do the job, so I'm not going to worry too much about that. And the way I'm going to attach the power connector is using these two 3D printed pieces where it sandwiches over the top of the connector, and I can screw them together and then screw this to the back panel. I've also added some threaded inserts to the Noctua fan. I know some people will probably be unhappy with this, but it will do the job. This is the Ethernet cable I'll be using. It's designed for panel mount. It's got 2 threaded holes there, so I can just attach that on there like that. And here I have a hole where I can feed the fan cables through. And I have some places for cable ties here so that I can attach the Ethernet cable so that it keeps the cable out of the way of the fan. And the Ethernet cable just attaches to this connector here. And I've cable tied it out the way, and it sits in there nicely. And this groove here is where the power cable sits, so it stays out the way of the chassis fan. I've routed the 2 front fan cables through here into a splitter and into the fan speed controller. I have this connector here ready for the bottom fan. That will just attach there like that when the bottom panel goes on. And I've realised I put the top panel round the wrong way, so I need to change that. Now with the top and bottom panel on, I can attach the fan. And I've attached a few cable ties to stop the cables from jiggling around when it's moved. And before I put the front panel on, I need to power it up and just adjust the fan speed to make sure that it's quiet enough. So as soon as I plug this cable in, the fan should spin up. And they do. So now I just need to flip it round to adjust the speed. So I'm going to turn it all the way down to the minimum and then turn it up so the fans only just turn on. So that's the front 2 fans on, and I can feel the bottom fan blowing as well. And we can see the router's powered up and the 2 buck boost converters have power. So before I put this front panel on, I'm just going to make sure the PC boots up and I can access the hard drive and everything. And then I'll get on and design the side panels. And I've confirmed the PC boots up now, so I can unplug it and attach the front panel. I just need to design some panels that can slot into these slots here. And then it's done. Oh, and attach the feet, because we don't want the fan sucking the desk. It needs to be raised up slightly. And just like that, we have the outer bit printed. I decided to go for a bit of a hexagon pattern to match the fans on the PC. I was umming and ahhing about how to print the panels, and I ultimately decided to print it in one piece, but I did print some test pieces just to make sure that it would print okay. So I tested printing it facing up, facing down, and on its side, but the piece that I tested, I printed on its side like that, so the flat bit of the hexagon was on the bottom. So I decided to change it so the hexagons had the point at the bottom and the top, so that it would print a bit better. This then meant I could print it all in one piece, so it would be a nice continuous panel. I ended up printing some of these tabs to just slot into the holes like that, so that the side panel wouldn't move around when the top and bottom panel were attached. Where before I wasn't sure how I was going to do the side panels, I didn't really think about these tabs. I thought leaving these grooves in would give me some flexibility, but what I should have done was print the tabs onto this piece so that this could be printed facing down without any print issues with the tabs. And then this could be printed laying flat on the bed without needing to worry about adding these in later. So let's put it all together and see how it looks. I can see that the corners are lifting up slightly, so I'm going to put a bit of glue down. It would just mean that I need to take the side panel off with the top panel if I need to get access to the PC. Okay, so that's the side panel in now. I'm going to screw the top on. What what I probably should have done as well is put some screws in the corners just to keep the corners held in, but the super glue's done a pretty decent job of that. Maybe with the exception of this corner here, but there's not really much I'm willing to do about that now. It looks pretty good otherwise, I think. And I've 3D printed some TPU feet to go on the bottom, with the intention of putting an M3 screw in, just to screw into the threaded inserts that I've got on the bottom panel. So that's all the feet in place now, so that's job done. And there we go. If you liked this style of video, give me a like and a subscribe, and I might make some more of them.